Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have n to the power of 6 minus 64 equals to 0. So here we find all the 6 roots of this problem or this equation. So the very first thing we are going to do is, here first we rewrite this equation as n to the power of 6. We write it as n squared and its whole cubed minus, we write this 64 as 4 cubed, and this whole equation equals to 0. And in the next step we will use here the well-known cubic identity or cubic formula, which will be looks like in this form: a cubed minus b cubed equals to a minus b times of a squared plus ab plus b squared. Okay, after this step we will use this nice formula. So here we have this is the value of a and this is the value of b. So now we put the value of a and b in this nice formula, and we will get its output in this form. So we get n squared minus 4 times of n squared and its whole squared plus ab. So a is n squared and b is 4, and plus b squared, and b is 4 squared, and this whole equation equals to 0. So after applying this formula we will be get our output in this form. And after this step we have two cases here. So our first case is, we write n squared minus 4 equals to 0, and the other case is we write n squared and its whole squared plus 4 times of n squared plus the square of 4 equals to 16, and this whole equals to 0. So in order to find the roots of given equation we need to solve these two equations. So now first I can solve this case. So in this case we find the value of n and we move this minus 4 in the right hand side, and we obtain n squared equals to 4. So here you take the square root on both of the sides, and we get the two roots of this equation, and these roots are n equals to plus minus 2. So these are the first two real roots of the given nice equation. So now in order to find the other roots we need to solve this equation. So now first I can simplify, I can write this equation into the simplified form, and after that we will solve this equation. So that here I can just take y equals to n squared. So when you put y equals n squared, then you obtained y squared plus 4 times of y plus 16 equals to 0. So that here this equation will becomes in quadratic form, and we need to use the quadratic formula. So that we have a equals to 1, b equals to 4, c equals to 16, and we write or our nice quadratic formula will be looks like in this form: y equals to minus b plus minus b squared minus 4 times of ac and this whole over 2 times of a. So this is our nice quadratic formula, and now we put all the values of a, b and c in this nice formula, and we get its output in this form. So that we have y equals to minus b, so the value of b is 4, so it will becomes minus 4 plus minus square root of b squared, and b is 4 squared minus 4 times of a is 1 and c is 16, and this whole over 2 times of a, and a is 1. So now we make little bit simplifications here, and we get our y equals to minus 4 plus minus square root of 4 squared equals to 16 minus 16 4s are 64, and this whole over 2. And after that we need to simplify this equation, and we move our final answer, and here we have y equals to minus 4 plus minus 16 minus 64 equals to minus 48 square root over 2. And you see here we can write this 48 as, so here first I can break the square root of minus term and 48, and we write it as minus 4 plus minus square root of 48 and square root of minus 1 over 2. So that we will write, or we get its output in this form. We have minus 4 plus minus, we will write this 48 as 16 times of 3. You know that 16 times of 3 equals to 48, and again you know that the square root of minus 1 equals to iota, and this whole over 2. So now in the next step you will just open the square root of 16, and we will write it as minus 4 plus minus 4 times of square root of 3 iota over 2. And now we will separate the terms, and we write it as minus 4 over 2 plus minus 4 times of square root of 3 over 2 into iota. And now we cancelled the terms, and we write, I can write here minus 2 plus minus 2 times of square root of 3 iota, and this is the value of y. And now we will just back substitute the value of y, and in the start of the problem we will put here our y equals to n square, so it will becomes n squared equals to minus 2 plus minus 2 times of square root of 3 iota. So in the next step we will take the square root on both of the sides, and we obtain n equals to plus minus square root of minus 2 plus minus 2 times of square root of 3 iota. So this is the our fourth roots of the given equation, and these are the two roots of the given equation. So these are the total 6 roots of the given equation, and this is our final answer of this problem. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.